first page of the equivalent fractions homework is scaling up. So all of these fractions need to be made bigger. The numbers in these fractions need to be made bigger to make equivalent fractions. Although the numbers will be bigger, the fractions themselves will be the same value. So if we look at on my first fraction, I have 1/5, and that is equal to a certain number of 30ths. Now if I started off with fifths, that means my entire whole was cut into 5 pieces, and now they're cut into 30 pieces. That means I've cut each section into an additional 6 pieces. I've got 6 times as many pieces. If I've got 6 times as many pieces for the denominator, I need 6 times as many pieces for the numerator. 1 times 6 is 6. So my first answer is 6/30ths. Next one, again, I started off with 4 pieces in my whole. I now have 20 pieces that make up my whole. So each piece must be divided into 5 pieces, and with 5 times as many pieces. If these pieces have been divided into 5, well, these are the same, there's 3 of them, so they must also be 5 times as many, giving me 15/20ths. I'm not going to write the multiplication on the top line anymore because it's a bit difficult to read when we do that, so I'll just draw the arrow. So here we've already got the numerator. We know that there were 5 pieces and now there are 25 pieces. So again, we've got 5 times as many pieces. So if we've got 5 times as many pieces, there must be out of 5 times as many pieces. Whatever's happened to the numerator must happen to the denominator. 35. 7 times 5 is 35. And what's happened here? I've gone from 7 pieces to 56 pieces. I've got 8 times as many pieces, which means my whole must be divided into 8 times as many pieces, which is 10 times 8, 80. Now, I know that people like the answer, in inverted commas, to be on the right hand side and the question to be on the left hand side, but let's face it, we can have a blank anywhere because this sign is not directional, it means is equal to. So a certain number of 81ths are equal to 4 ninths. So if I'm thinking about ninths, I've got 4 of them. If I'm thinking about 81ths, I've got 9 times as many, which means I have not just 4, I have 9 times as many. 9 times as many as 4 is 36. I'm thinking about quarters, I've got 3 of them, but if I've got 40ths, I've got 10 times as many pieces, which means I've got 10 times as many in my numerator. I've got 4 of something, which is equal to 2/11ths. Well, I've got, instead of 4 pieces, I've now got 2 pieces. So instead of multiplying, I've squished my pieces together to make bigger pieces. I've only got half the number of pieces, or you could say I've divided the number of pieces by 2. So whatever happens to this one must happen to this one. We could go, I'm such a silly Billy, I should have done the arrow the other way, shouldn't I? I won't do the arrow that way, timesing by 2, that's much easier, 22. All I can say is exactly, that's my excuse. So here I'm actually going to do it the right way this time. It's 12 something, so the same as 3/20ths. Well, instead of having 3 of them, I need 12 of them, which means I need 4 times as many. So I need 4 times as many. Instead of 20ths, they're now 4 times 20, which is 80ths. There we go, got there in the end. Now, this question on the back here, the bubble question, the first one, the best thing to do is to try and divide the fractions down. So, let's start off with 8/24ths. Right. Can I smush that down at all? Yes, I can. If you look, 8 and 24 can both be put into groups of 2, into groups of 4, and into groups of 8. So if I put them both into groups of 8, that means my 8 pieces becomes 1 piece, and my 24 pieces becomes 3 pieces. Now I know this fraction has no more equivalent fractions because smaller equivalent fractions because it's a unit fraction. So I know straight away that this one and this one match. Excellent. Let's look at another one. Let's look at 5/15ths. Okay, so can I put those into any groups? I can put those into groups of 5. I can put those into groups of 5 or 3. but I can only put them both into groups of 5. So let's do some dividing by 5. 1, 3. Oh look, that one's the same as well. I'm going to use green to circle it, just to show that all these are the same. So one of these might fit the pattern and one of them might not. Let's see. 3, 6. What can I do with those? I can put both of those into groups of 3. So that 3 is one group of 3. 6 is 2 groups of 3. Does that fit? No, it doesn't. So I'm going to put a cloud around that one. And then what should happen is this one should also go to 1 over 3, but let's just check. 4 over 12. I can put those into groups of 2 or into groups of 4. Let's choose the biggest number of groups. Put that into 4 groups of 4. That I've got 1 group of 4. If I put that into groups of 4, I've got 3 groups of 4. 1/3. So this is also 1/3. The odd one out is 3, 6. Now, here you can be as imaginative as you like. I know that my year 7 class like to give me huge numbers, so I imagine I would get some 2 million over 9 million if there was room in the boxes, but they're only 2-digit boxes, so you're out of luck. There are 2 ways to do this. One way, the easiest way, is just to write out the multiplication tables. So 2 ninths, that's one group of 2 and one group of 9. If I split them into 2 each, 4, 18. If I split each of these into 3 each, I'd have 6 and 27. Can you see that we've got the 2 times table on the top and the numerators, and we've got the 9 times table as the denominators. So we could just do that for a few more. What should I put 9 there? 8, 10, 27, 36, 45, and I could write those ones in. Or you could just choose your own large number. I could say, okay, I want to make it 8 times bigger. 8 times as many pieces. 2 times 8 is 16. 9 times 8 is 72. Either of those methods will work. This one is quicker, this one is more interesting. Up to you which method you use.